Hi guys, my name is Aksa Khalid and I am here with another video about numerical solutions. This time I am going to solve the third question from quantum mechanics by Zeitili of first chapter. Two questions are already solved and the video is available in my YouTube channel. You can go and check there. And if you want to know the solution of these first two questions, in this I am going to start from the third question. Okay. And you will also find the pictures of these solutions in my Facebook group. So a link will be in the description box, so you can go there and check it out if you people want. And now let's start. In this question, consider a 75 watt light bulb and an 850 watt microwave oven. If the wavelength of the radiation they emit are 500 nanometer and 150 millimeter respectively, 500 nanometer wavelength is for the radiations emitting from the light bulb, and 150 millimeter wavelength is for the radiations emitting from the microwave oven. Estimate the number of photons they emit per second. We have to find the number of photons which are emitting from these two sources in 1 second. The time is given is 1 second, and after that we have to after that when we get our results, and then we have to discuss the quantum effects in quantum effects for both these sources, and we have to told them the basic of the given answers, that either the quantum effects important or not in these two cases. Okay, I will start from finding the number of photons for the light bulb, and then I will do for the microwave oven. So let's start. 75 watt mean a power is given. Okay, given data for light bulb. Okay, power P is equal to 75 watt. Okay, at first I'm going to do the at first I'm going to tell you that power is not required in for this question. Actually the requirement is energy. So I'm going to convert the power into the energy, as power and energy are related to each other with this formula. Time is given is 1 second, as I already told you, and power is 75 watt. Okay, and P multiplied with time, power multiplied with time is equal to energy. Power is 75 watt and time is 1 second, and this will become equal to 75 joule energy. Okay, because energy is required to solve this question, not power. Power is just a you may say that a helping element to find the energy. And then we have the wavelength, lambda L, say that for the light bulb, and 500 nanometer, which will be equal to 500 into 10 raised to power minus 9 meter. Okay, at first let me show you the formula with which we can find the number of photons emitting from the light bulb. And number of photons will be represented with N, and it is equal to E over HF. Okay, I'm going to clear one thing, that in the book this F is represented with this symbol. Okay, almost related to V. Okay, with this symbol, almost related to velocity. And but to avoid any confusion, I'm going to represent it with F. Otherwise in book it is represented with this symbol. I'm going to represent with F because here is a frequency, we have to find it. Okay, we have the value of energy. We know the value of the Planck constant, but we have to find the frequency, because frequency is not given in the question. We have to find it, and as we know that frequency is equal to F is equal to C over lambda, mean wavelength of the source. C is the speed of light, which is equal to 3 into 10 raised to power 8 meter per second, and lambda is 500 for the light bulb, which is currently our source to emit photons, into 10 raised to power minus 9 meter. Meter will be cancelled with meter, and after solving this I get the value of frequency which is equal to 6 into 10 raised to power 14 per second. Per second is the unit of frequency. Hertz is also the unit of frequency, and per cycle is also the unit of frequency. I wrote per second because I derived it from this formula, and you may change it into hertz. It doesn't affect the solution of your question. Okay, now let's find the number of photons, because now we have the value of energy, we have the value of Planck constant, which is a constant we already know, it has fixed value, and the value of frequency, which we already find. And now after putting these values, after putting all these value in this formula, I get this equation, 75 joule, 6.634 into 10 raised to power minus 34 joule second, the value of the Planck constant, and then the value of the frequency. I also put the unit here so that you can get the clear idea that number of photons doesn't have any unit, because joule will be cancelled with joule, and second will be cancelled with per second. After solving this equation, I get the value of number of photons, which is equal to 1.88 into 10 raised to power 20. As number of photons should be an integral value, so I am going to round off this number into 2 into 10 raised to power 20, and the number of photons wouldn't have any unit, as you already see in this equation that how all the units are cancelled out. These are the number of photons which are emitting from the light bulb. Now let's find the number of photons which are emitting from the microwave oven, and for that we have to do the same procedure again. Okay, now let's find the value of energy, and then the value of frequency, and after putting in the same formula we will get again the number of photons, but this time for the microwave oven. For microwave oven, power is equal to 850 watt, which after solving will equal to 850 joule, and you already get a clear idea that how I can get this value, and so I'm going to write this value as it is without solving. And now the value of the frequency we have to find. Frequency will be equal to speed of light divided with the wavelength of the radiations, now this time which are emitting from the microwave oven, and so I'm going to write it lambda m. That wavelength of the radiations which are emitting from the microwave oven is equal to lambda m is equal to 150 millimeter. Milli is equal to 10 raised to power minus 3. These radiations are of quite longer wavelength as compared to that of the which are emitting from a light bulb. After putting these values in this formula, C is equal to 3 into 10 raised to power 8 meter per second. Lambda is equal to 150 into 10 raised to power minus 3 meter. Meter will be cancelled with meter, and the per second is the unit of frequency. 3 divided by 150 multiplied by 10 raised to power 8 plus 3 per second. After solving this, I get the value of frequency 0.02 into 10 raised to power 11 per second. Okay, now put all these values in the formula, which is equal to for the number of photons, E over H and F. The value of E in this case 850 joule, and 6.634 into 10 raised to power minus 34 joule second, and the frequency is equal to 0.02 into 10 raised to power 11 per second. Okay, as you already see that all these the units will be cancelled out, and number of photon has no unit, so it will be an integral value. After solving these values, I got number of photons are equal to 6.4 into 10 raised to power 26 without any unit. Number of photons should be an integral value, so I'm going to round off this value into 6 into 10 raised to power 26. Number of photons which are emitting from the wave over with wavelength 150 millimeter and the energy 850 joule. Okay, now let's talk about the second part of this question, in which we have to explore either quantum effects are important in these two situations or not. Let me explain it to you that quantum effects will important when there are less number of photons emitting from these sources. Now in these two cases, number of photons are very greater. A huge amount of photons are emitting in these from these two sources. As from the bulb, the value of the number of photons 2 into 10 raised to power 20, and for microwave oven the value is 6 into 10 raised to power 26. As the number of photons are larger, that's why quantum effects are not necessary there. And let's move towards the next question. In the next question, we have to assume that a given star radiates like a black body. Okay, this is a condition. Keep in mind, estimate the temperature at its surface and the wavelength of its strongest radiation, and when it emits total intensity of the value of 575 megawatt per meter square. Mega is a prefix which will be equal to 10 raised to power 6. Okay, now let's move towards the solution of this question. Okay, as the body is the black body, so the value of A for a black body is equal to 1. Okay, and the intensity is equal to I. Oh, sorry. The formula for intensity is equal to Stephen Boltzmann constant, the value of A for a black body, which is equal to 1, and the temperature per 4. Okay, intensity is given in the book. Another symbol is used for the intensity, but I'm going to avoid from any confusion, so that I used I for the intensity. And intensity is equal to 575 mega will be equal to 10 raised to power 6 watt per meter square, and the value of sigma is equal to 5.67 into 10 raised to power minus 8 watt per meter square per 4 Kelvin. Watt per meter square per 4 Kelvin, and the value of A is equal to 1 for a black body, and T we have to find, so it will remain as it is. Okay, because this value is multiplying here, so on the other side of the equation it will be divided. Okay, it's divided with this value, watt per meter square, and 5.67, which is the value of Stephen Boltzmann constant, and watt per meter square per 4 Kelvin, and it is equal to T. Keep T per 4. Okay, watt and these two units will be cancelled with this one. K will be when moved to the K when moved in the numerator, it becomes plus 4. After solving this, now we have to take 1 over 4th power on both sides, so that we will be able to remove 4th from these two values, because we have to find the value of temperature T, not the 4th power of temperature. 101.4 into 10 raised to power 14 K4 1 over 4, and T 4 into 1 over 4. This becomes T, and after solving this equation I get 1.0034 into 10 raised to power 4 Kelvin. Okay, this is the temperature which they asked for, and we did it. Now let's move towards the part B of this question, in which we have to find the wavelength for the strongest radiation. Okay, let's start. Okay, according to Wien's displacement law, if you want to find wavelength, then you have to use this formula. Lambda multiplied with temperature is equal to the Wien's displacement constant, 2.898 into 10 raised to power minus 3. It also has some units. Okay, just find it out from anywhere, either from the internet or from your book. I am not going to put here. And wavelength we have to find and temperature we already did. Let me put its value here. As it is multiplying here, so on the other side of the question it will be divide, and its value is 1.0034 in 10 raised to power 4. 1.0034 into 10 raised to power 4. After solving it, 8 into 10 raised to power minus 7, and it will become its unit is meter wavelength. Okay, as in physics we are used to write wavelength in the nanometer, so let it is let at first convert it here. 8 into 10 raised to power minus 7 multiplied with 10 raised to power minus 2 to make it nano, and 10 raised to power minus 2 we divide it here, and this value will become equal to nanometer, so 2.88 is equal to 10 raised to power plus 2. When this value moves to the numerator it becomes plus 2, and this value becomes equal to nano, so nanometer. The noise behind. When decimal point moves towards this direction, it becomes equal to 10 raised to power minus 2 multiplied with 10 raised to power 2 nanometer. Both these numbers will neutralize, and so at the end we get wavelength is equal to 288 nanometer. I hope it will make sense to you, and if yes, then let me know in the comment section, and if you want to